In this video, we will look closer at the use of autonomous vehicles in the AFarCloud project. We will illustrate how autonomous vehicles, such as the AFarCloud vehicles shown here, can be integrated with the middleware and help farmers to implement precision farming methods and reduce the need for manual farm labor. All autonomous vehicles with an onboard computer running ROS can easily be integrated with the framework by downloading the DDS client and connecting with the DDS interface of the AFarCloud platform. A wide selection of onboard computers are available for this purpose depending on the processing requirements for the particular mission. A popular choice is the Jetson Nano and the Raspberry Pi. Now we have an AFarCloud integrated flying sensor platform that can be outfitted to fit the mission requirements. An increasing amount of drone-sized, off-the-shelf sensors and equipment are entering the market, such as multispectral cameras for NDVI estimation, LiDARs for distance measurements, and RTK GPS for high-accuracy positioning. An important aspect of agricultural drone solutions is how the technology can be brought to the average farmer in an efficient and affordable manner. One solution can be to establish services where long-range fixed-wing drones can fly missions covering large areas and making the collected sensor data available through a prescription solution or a drone-as-a-service solution. Here we see the fixed-wing UAV developed by a AFarCloud partner, Maritime Robotics. It can carry up to 6 kilograms of payload and handle challenging conditions. The Falk UAV is shown here flying an MMT mission. The mission is planned in the MMT, then the UAV takes off and flies the MMT path and performs the assigned tasks. Here it's specifically looking to detect undesirable objects or animals in the field, for instance prior to harvesting. If trash is ground up together with the feed, this can lead to serious injury or death if the animals consume it. If an object is detected, the onboard software can send a point of interest observation to the MMT so that the farmer can decide if an action should be taken. Multirotor UAVs are useful to cover smaller areas and for missions that require either low speeds or high maneuverability. Unfortunately, multirotors are energy inefficient and the operating time is typically limited to 20 to 30 minutes. To address this problem and lengthen the window of autonomous operations to free up the farmer, the UAV should be supported by a ground station that allows the UAV to charge autonomously. For a large farm, a mobile charging station can be an advantage. The charging stations are heavy and bulky, and placement on a wheeled platform will make it easier to move the equipment around the farm to where it's needed. The AGV-hosted charging would extend the autonomy of the UAV significantly, and the AGV could additionally support the mission by carrying, for instance, a bin for collection of fruit or garbage picked by the UAV. The AGV could even carry equipment to analyze samples collected by the UAV. The AGV can also perform other types of missions in parallel with the UAV, such as collecting soil samples, measuring soil stiffness, or weeding. When the UAV needs to recharge, it can return to the mobile charging station to charge by receiving its position from the MMT. This footage shows a mission involving two autonomous vehicles, a UAV and an AGV that carries a mock-up charging station for the drone, where both receives an MMT mission. The UAV takes off and flies to a selected point of interest on the MMT to perform a task. When the UAV needs to charge or is finished with its mission, it will return to the AGV and land autonomously. The autonomous landing is possible due to the RTK GPS capability of the drone that results in centimeter level precision, but also visual navigation is used for extra safety. In the project, we use an off-the-shelf hardware solution with an IR lock sensor and LiDAR mounted on the drone and a Mark I beacon installed on the landing platform. Let's also have a closer look at the drone manipulator. It consists of a housing that attaches to the drone, a long pole to provide a safe distance between the drone and the environment, and an end-mass. In this case, the end-mass is a simple temperature probe, but there are many alternatives that could be adopted for other types of missions. Just grippers to retrieve garbage, a cutter to retrieve plant samples, and possibly even devices to collect soil samples or provide pollination. The drone manipulator is designed to be self-sufficient by including dedicated batteries and communication via Bluetooth Low Energy. This allows for quick and easy payload attachment, and the wireless interface means that the safety and integrity of the UAV itself is not compromised. Microprocessor for the payload, in this case an Arduino Nano 33BLE, can receive commands to deploy the manipulator from the UAV onboard computer, who again receives missions from the MMT. Similarly, the manipulator payload can send relevant sensor data via the drone to the MMT. Here the drone is on site in San Rosore and ready to fly a mission where it performs a temperature measurement at a desired position. The operator can plan the autonomous mission in the MMT. The operator is notified when the mission is defined successfully. The drone takes off. The mission progress can be monitored on the MMT. Here we see the drone mission as captured by another UAV. When the desired location for the measurement is reached, the drone descends to the desired altitude and deploys the manipulator. When the data is collected, the manipulator is stowed and the mission continues. Finally, let's summarize the main points made in this video. It's possible to coordinate a wide variety of autonomous systems from the AFarCloud MMT and to send the sensor data from the mobile platforms in real time to the AFarCloud middleware. Mobile drone charging station allows us to extend the time that the drone can work unattended, once the regulations fully open up for this. It is also possible to design practical wireless drone manipulator payloads that can easily be attached to a wide range of drones to collect in-situ measurements.